this lesson, we're going to learn about the commutative property of addition and the commutative property of multiplication. Let's start with the commutative property of addition. So if we consider this expression, negative 12 plus 7, we can evaluate this in two different ways. We can say that negative 12 plus 7 is equal to negative 5. But we can also reverse the order of the terms and say that 7 plus negative 12 is also equal to negative 5. So I can conclude that negative 12 plus 7 is the same as 7 plus negative 12. Reversing the order of the terms didn't change the result. They're both equal to negative 5. Now let's consider a second example, 20x minus 18x. So if I keep the expression the same as 20x minus 18x, this is going to result in 2x. But what happens if I reverse the order of the terms and say that negative 18x plus 20x, this is equal to, well, this is also equal to 2x. So 20x minus 18x is the same as negative 18x plus 20x. What we're observing in these two examples is known as the commutative property of addition, and it just says that the order of the terms doesn't matter when we're adding. Negative 12 plus 7 is the same as 7 plus negative 12, and 20x minus 18x is the same as negative 18x plus 20x. So as a formula, the commutative property of addition can be written as a plus b is equal to b plus a. It doesn't matter the order in which we add the terms. A plus b is going to give the same result as b plus a. Now let's look at the commutative property of multiplication, and it's going to give us the same type of result. If we consider negative 2 times 13, we can say that negative 2 times 13 will give negative 26. But if we reverse the order of the terms and say that 13 times negative 2 is equal to, well, this is also negative 26. So we'll conclude that negative 2 times 13 is the same as 13 times negative 2. Just like with addition, the order in which we multiply doesn't matter. In this example, the result is still negative 26. In this last example, we have 5 times 8y to the second. So if we evaluate 5 times 8y to the second, we get a result of 40y to the second. But if we reverse the order of the terms and say that 8y to the second times 5 is equal to, well, we still get a result of 40y to the second. So we can say that 5 times 8y to the second is the same as 8y to the second times 5, because they're both equal to 40y to the second. This is the commutative property of multiplication. It's very similar to the commutative property of addition. And it just says the order in which you multiply doesn't matter. So as a formula, we'll say that the commutative property of multiplication is a times b is equal to b times a. So we have two different versions of the commutative property. We have the commutative property of addition, which says that a plus b is equal to b plus a. The order in which we add doesn't matter. And the commutative property of multiplication, which says that a times b is equal to b times a, which says the order in which we multiply doesn't matter.